So in Unit 4 today, this will be lesson number 9, systems of nonlinear equations. So we've learned all sorts of equations that are not linear. We worked with parabolas and snake-looking things and all sorts of graphs that are not linear. Another interesting equation here that, just to mention is the circle equation. To graph a circle, the equation can be represented by x squared plus y squared equals 25. One of the things in a circle is, the center of the circle would be 0, 0. So if we have x squared plus y squared equals 25, there is no vertical or horizontal shifts. The 25 over here, if you take the square root of it, that actually represents the radius. So r would equal 5 as the radius. So it's an interesting thing about some equations, they can take on the effect of a circle. Notice how we have x plus 3 squared and y minus 2 squared equals 25. Remember, since these are inside, that means there's a horizontal shift left 3. So the center of the circle would now be left 3, and there's also a shift in the y's. And this is again backwards here in this case because this is a little bit different equation. So this is going to actually be to the right 2 as well. So this is going to be a little bit different than the transformations we did, but these are actually going to be both backwards, the -3 and a +2, and the radius would equal, again, this 5. So if I had that information, I could actually rough out a graph of this on a piece of graph paper. Like I said, there are all sorts of shapes you can create. You could explore a lot of these if you want by, just doing your own research. And Khan Academy is an excellent free resource for a lot of math topics. Feel free to explore what's called conic sections. Conic sections are really cool. If you're wanting to do something in the summer here, that would be something cool to explore that I kind of enjoy. It kind of goes along these lines here. Anyway, solving a system of linear equations, we're going to just use what's called the substitution method as our strategy. So 2x squared plus y squared equals 18. Notice how this kind of looks like the equation of a circle, but the only catch is there's this coefficient in front of the 2, which causes a kind of a stretch, if you will. And if you kind of stretch a circle, it's going to kind of make it more look like an ellipse. So this is going to have more of a characteristic of an ellipse, so not quite perfectly a circle. X times y equals 4, that's actually going to represent what's called a reciprocal function. So if we want to graph that, we could. So now, again, though, all we're really interested in this lesson is basically, instead of graphing them, we're really just interested in trying to find the values of x and y that make these equations true. Now, remember, the solutions are the point of intersections. So there can be more than one point of intersection in these types of equations. So using the substitution method, I'm going to solve the second equation for y. So it's going to be y equals 4 over x. Excuse me. So this equation is a lot easier to solve for y or x than the top equation because you're going to have some plus or minuses there, which creates a complication. So now we're going to replace y with this 4 over x squared. So this becomes then 2x squared plus 4 over x squared equals then this 18. So what we can do now is simplify the left side by squaring the 4 over x. So this turns into 2x squared plus 4 over x squared. And that's, I'm sorry, 4 squared is not 4, is it? 4 squared is actually 16. See if I can get that to work here. Okay, so I have 16 here, and that's going to equal then this 18 squared. Now, again, to solve equations, we don't like to have fractions, so we can multiply by the common denominator, which is actually going to be an x squared. And what I can do is multiply each side by this x squared. So 2x or x squared times 2x squared, that's going to actually become 2x to the 4th. See if I can get a little bit more room this way. So this is going to become 2x to the 4th. And then here, the x squareds are going to divide out to give me just plus 16. And then that's going to equal then 18 times x squared is going to be x squared. So this kind of looks quadratic in a sense that we have these powers here. So let's set this equal to 0 and see what we can pick up on here. So I'm going to subtract the 18x squared on both sides. So that's going to come in the middle here. Because remember, one from highest degree to lowest degree. So my 18x squared would fall into there. Plus 16 is an equal to 0. One thing I also can pick up on is each of these terms is even. So I can divide each one of those terms by 2. So this turns into x to the 4th minus 9x squared. And 16 divided by 2 would be 8 equals 0. Now what I can do there to make it look more quadratic, what I could do is say let u equal x squared. By doing so, I can now change this to u squared minus 9u plus 8. Because again, x to the 4th would be the same thing as x squared to the 2nd power. So x squared to the 2nd power is the same thing as x to the 4th. But if I replace x squared with u, that just turns into u squared. And this is going to equal 0. Now, if I look at that, that looks factorable. So I can write this as u, and the factors of 8 that would give me a 9 would be like a 1 and an 8. But to be a negative 9, they both have to be negative. So u minus 1 and u minus 8 is equal to 0. So if we solve for u, we should get u equals 1 and u equals 8. Now, again, we're not solving for u, we're solving for x. So we have to remember to substitute that back in, x squared back in. So x squared is equal to 1 and x squared is equal to 8. If we solve those for x now, we have to take the square root of both sides, but remember, that can be a positive or a negative 1. So that actually promotes 2 solutions. And if I have x, that would equal plus or minus the square root of 8. But remember, the square root of 8 is the same thing as the square root of 4 times 2 in there, which means I actually can take the square root of 4 and that comes out as a 2. So this becomes then plus or minus 2 square root of 2. So actually I have 4 values for x. Now, I can find y by using this equation here. So y equals 4 over x. So I'm going to come down here and I'm going to say now, y is equal to 4 over x. And what I could do is take one of these at a time, substitute 1 in to start with. So y is going to equal 4 over 1, which is going to give me 4. So 1, 4 would be a solution. If I put negative 1 in for x, that's just going to be, again, y equals 4 over x. That's going to be y equals 4 over negative 1. That's going to give me a negative 4. So negative 1, negative 4 would be a solution. Now, the next one I have to put in would be like 2 square root of 2. So this would be y equals 4 over 2 square root of 2. Notice that I can divide a 2 out of the top and bottom. This becomes 2 over the square root of 2. But we learned in an earlier unit that you're not allowed to leave a radical on the bottom. So to rationalize this, what we can do is multiply the top and bottom by the square root of 2. So by doing that, this becomes then 2 square root of 2 over 2. And also, again, the 2's can divide out, and that leaves me the square root of 2. So that means another solution was we put 2 square root of 2 in, and we got square root of 2 out. So another solution would be 2 square root of 2 went in, and the square root of 2 came out. So that'd be a third solution, a third order pair, third point of intersection. We also could put a negative 2 square root of 2 in. So if I put that in, it'd be like 4 over negative 2 square root of 2. Again, notice how 4 divided by negative 2, I could divide out, take out the 2 there, and I like to keep the negative in the top. So this is going to be a negative 2 over the square root of 2. And then I can, again, get rid of the radical on the bottom, but multiply the top and bottom by the square root of 2. So this becomes negative 2 square root of 2 over 2. Notice how the twos would divide out, and you'd be left with negative square root of 2. That should make sense. So we end up within a fourth order pair, which would be negative 2 square root of 2, negative square root of 2. So that would be my 4 solutions to that problem. So if I want to solve this equation, it's now so y equals 3x plus 2 is linear, but 3x plus y squared equals 4. Again, that's not linear. That's more elliptical again. So to do this, sounds like there can be just 2 intersection points here. So let's see what actually happens here as we move on. So again, notice how this is our soft y. So I'm going to substitute y into the second equation and just see what happens here. 3x squared equals then, plus then. I'm going to replace y with 3x plus 2. This becomes 3x plus 2 squared is equal to 4. So the 3x plus 2 is going to be substituted in for y, and that's going to give me 3x squared plus the quantity 3x plus 2 squared. So I can go ahead and simplify this with squaring out the 3x plus 2. Remember, that's going to be a trinomial. So 3x squared, and then 3x times 3x would be 9x squared. And then you multiply 3x times 2 and double it, that'd be 12x. And square the 2 would give me then the 4. That equals then 4. So this kind of looks quadratic. So I can combine the 3x squared and the 9x squared together. That's going to give me a 12x squared. Plus then this 12x. And when I subtract 4 over, the 4's cancel out. This just gives me 0. So what I pick up on now is these actually have a GCF of 12x in them. So I can actually factor out a 12x. And that's going to give me then x plus 1. So now all I got to do is set the factors equal to 0. Well, 12 doesn't need to be set equal to 0, just the x equals 0. And then I set x plus 1 equal to 0. And x does equal a negative 1. So 0 and negative 1 are your 2 values for x. And like I said, a line hitting an ellipse seemed like it is all going to hit 2 spots. So I'm feeling pretty good about that. So to find the corresponding y value, so when x equals 0, I can substitute back into the original one that's solved for y. That gives me y equals 3 times 0 plus 2, and that's going to equal 2. So 0, 2 would be a point of intersection. The other one I have is x equals negative 1. So if x equals negative 1, if I substitute that in, I get y equals 3 times negative 1 plus 2. That's going to be negative 3 plus 2. That's going to be a negative 1. So it looks like another solution is going to be negative 1, negative 1. So that would be the other point of intersection. So again, we could graph these 2 problems and try to find the point of intersection using your graphing utility. But I thought it was kind of interesting to just do this algebraically. So that concludes this lesson. Hey there.